Hi, today we're going to do section 4.1, the first derivative test. Sorry, it's taking a second to pull up my notes. Okay, let's see. So we are going to talk about how we can find things out about f given what we know about f prime. So in general, remember f prime is the derivative, and the derivative is the slope. Okay, so what does it mean for a function to be increasing? It means the function is going up. That's what this is saying, right? That one y value here is greater than this y value here. And then a function will be decreasing if the reverse is happening. The further you move along x, the smaller the y values get. But there is a more technical way to define increasing and decreasing based on the derivative. So this is the important concept right here. When f prime is positive, f is increasing, and when f prime is negative, f is decreasing. I usually write it like this, shorthand notation, f prime positive means f is increasing. F prime negative means f is decreasing. And I want you to understand why. F prime, again, is the slope. So if we have a positive slope, that means the function must be increasing to have that positive slope. And if the function is decreasing, then if we draw a tangent line, the slopes would be negative. Okay, so that's kind of the overall idea. I'm going to define something else called the critical number. The critical number is where the derivative equals 0 or doesn't exist. So the way we find a critical number or a partition number, it's where the derivative equals 0 or where it doesn't exist. Okay, and this is describing how we're going to do the first derivative test. We're going to take the derivative to find the critical numbers. We're going to put those on a number line, and then we're going to test points into the derivative to see if the function is increasing or decreasing. That gives us the max and mins. I think it's most helpful when we just do an example. So I have this function here. I want to figure out where it's increasing and decreasing. Anytime you see these words, increasing or decreasing, I want you to think f prime positive, f prime negative. And I'm going to do these steps. First, you're going to take the derivative. So we get 4x cubed minus 12x squared. Then you're going to take that derivative and set it equal to 0 or does not exist. We're going to need to consider that here when you have a fraction. Here it's a polynomial, so we have no issues there. I'm going to factor out the GCF, so I'm left with x minus 3. Then I'm going to set each factor equal to 0. So if I set each of these factors equal to 0, I get x equals 0 and x equals 3. Then I put these guys, which are called critical numbers, I put them on a number line, and the number line's name is f prime. And what we're going to do is we're going to pick points on these intervals, and we're going to test it into, I like to put it into this factored form of the derivative, because we're trying to figure out the sign of the derivative. And we're just going to use some common sense here. If I have two negatives, that is a positive. If I have a negative times a positive, that is a negative. And if I have a positive times a positive, that is a positive. So I don't actually usually write down the numbers I plug in. I just kind of mentally do it because I don't want you to get confused when we write out the intervals of increase and decrease. So we're picking something to the left of 0, like -1. I normally do not write -1. I'm going to do it really small right here just so you know what we're doing, but I usually don't even write that number. This right here is squared, so that will always actually be positive. So if I plug in a -1 here and subtract 3, that's going to be a negative number times a positive number out here. And a positive times a negative is a negative. If I plug in something over here, like 1, out here is positive, in here is going to be 1 minus 3. So that would be then a negative number. And a positive times a negative, hold on, what did I just say? 1 minus, yeah, it's still going to be negative. Okay, and if I plug in something over here like 4, or you could plug in 100, doesn't matter, anything to the right of 3. If I plug in that, I'm going to get a bigger number here than that one. So the overall result here is going to be positive. So you're going to have two positives, which gives you a positive. That means the function is decreasing on this interval, still decreasing, and then increasing. So if I want to write the intervals of increase, f is increasing from 3 to infinity. F is decreasing from -infinity to 3. This right here is a local max because the derivative changes signs, and you can kind of see it looks like, sorry, I said max, I meant min. It changes signs from negative to positive here. So if we want to find the local min, we would say x equals 3 is the location of the local min because f prime goes from negative to positive there. Okay, the next one, we take the derivative of this. The derivative, I'm going to rewrite it like this to take the derivative. When I take the derivative, I'm going to pull the negative down, keep the inside the same, subtract 1, multiply by the derivative of the inside, which is just 1. So we have negative 5 over x minus 1 squared. Now I take this derivative and I find its critical values, which is where the derivative equals 0, which in this case, negative 5 can never be 0. So we have no places where that happens. The other one is where it doesn't exist. That's where the bottom equals 0. So if I end up plug in things on either side of this guy's a little unique because if I plug in anything, this bottom is always going to be squared. So it's always going to be positive. And this top is always negative. So this function's derivative is actually always negative, which means the function is always decreasing. And for this, it's not defined at 1. There's an asymptote there. So the function is decreasing on its domain, which is negative infinity to 1 and 1 to infinity. So that is that function. So it doesn't have a max or min. F prime of c equals a horizontal tangent. So we're just trying to show you examples of where that could be true. So I have a horizontal tangent anytime if you zoomed in and it would be flat, right? So there'd be a horizontal tangent. It could be the location of a min, or it could be the location of a max. Or you could have this situation here where it's neither a max nor a min, and it's like changing concavity, but it's continuing on its path of increase or decrease. Then you have an example down here where f prime of c is not defined, but the function is, and so that would be at sharp turns or vertical tangents. Here the derivative is undefined, but the function has a value itself. Okay, where is this a graph of f or f prime? It says this shows a graph of the function f, so that's important because sometimes the graph will be f prime. This is a graph of f though, so what does it mean for f to increase? That just means going up. So from negative infinity to x equals p. I wonder if that's a or p. So where is x increasing? Where's the f increasing? It would be this interval here, this interval here. So from negative infinity to a and from b to f. Identify the intervals where f is decreasing. That would be the opposite one. So a to b and f to infinity. Where is f prime greater than 0? Same idea, f prime greater than 0. Remember I told you at the beginning of this lecture, f prime positive means f is increasing. So A and C are asking the same questions because it's where's the slope positive? Well, the slope is positive wherever the function is increasing. The slope is negative wherever the function is decreasing. So these two are asking the same thing. Identify the coordinates where f prime of x equals 0. So that's asking for a horizontal tangent line. So if I were to zoom in and zoom in and zoom in, it would have horizontal, a flat tangent line, which would be at x equals b and at x equals d and at x equals f. Where does f prime not exist? Now it's going to be at vertical tangent lines or sharp turns. So we have at x equals a, and then I think that g is supposed to be a vertical tangent line. Where does f have a local maximum? So that means it looks like a hilltop. Okay, so I want you to think that it looks like a hilltop, but what it means is the point here is relatively bigger than the ones around it. So that would be A and F. So it's kind of turning points in the graph where it looks like a hilltop. Local minimum then would be B. And I think that's all, just B. This is the graph of F again. Given the local extrema, construct a sign chart for f prime and then sketch a graph of f prime. Okay, so this is a graph of f. And I know that my horizontal tangents are where my critical values are, okay? So that would be at -5, 0, and 5. The function is increasing, which means the derivative will be positive. The function's decreasing, so the derivative will be negative, then the derivative is positive, then the derivative is negative. So again, function's increasing, decreasing, increasing, decreasing. This is a max, you can see it, and this is a min. This green line here that I drew, this right here represents this function. See how it goes up, down, up, down. Okay, but if I want to graph the derivative, I'm going to graph positive and negative, which means positive means above x-axis, and negative means below x-axis. So if I actually want to graph the derivative, what I'm going to do, anytime the derivative is 0, I'm going to graph it in red. Anytime this derivative is 0, which is it's going to be a 0 here on the graph. And what's going to happen is this here, the graph is increasing, f is increasing, so f prime is positive. Positive means above the x-axis. Now f is decreasing, so now f is going to be below the x-axis. Now f is increasing, so f is above, or f prime is above, decreasing, so now we are below. So that's an example of f prime. This function is increasing, its derivative is positive, and vice versa. Notice that this is a decreasing function, and it's something like x to the 4th, because anytime you have a w, that's a quartic. So if I take the derivative of this, I'm going to have something cubed, and cubics look like this. So it makes sense that my derivative will be a cubic. It's decreasing because this guy was opening down, but also it's decreasing because we follow the path. This function is increasing, which means the derivative starts off as above the x-axis because this is increasing. And the zeros of this derivative line up with the flat tangents of the function. All right, let's try another one. Now we have a graph of f prime. So now we're going backwards. This is where students sometimes struggle, but remember I said you need to know these 4 things: f prime positive, f is increasing, f prime negative, f is decreasing. So if I want to figure out where f is increasing, but this is a graph of f prime, I don't actually pick here because that's not where f is increasing. That's where f prime is increasing. I use this here. F is increasing if f prime is positive. Positive means above the x-axis. So the graph is positive here and here. So f prime is positive from -infinity to -2 and 2 to infinity. So f is increasing there because f prime is greater than 0 or positive. And then the function would be decreasing where f prime is negative. -2 to 2, f prime is f prime is negative, so f is decreasing. If I was going to go backwards now, okay, so that one's a little bit trickier. So this is, I'm going to find the zeros. Let's see, this is a 0 and this is a 0. This is going from positive to negative, which means it's going to be a max of the original function. And then this is going from negative to positive, which means a min of the original function. So this function is positive, which means the function f starts off as increasing, then it's going to change to decreasing, then it's going to change to increasing. So this could be a possible example. This horizontal tangent corresponds to that 0. This horizontal tangent corresponds to that 0. Again, listen to my words really carefully. This function is positive, so this function's derivative, f prime is positive, so f is increasing. F prime is positive here, so f is increasing. Then f prime is negative here, so that means its function is decreasing. And this right here, this 0, this is a max of f. It's a 0 of f prime, and the derivative is changing from positive to negative. And here at the minimum of f, this is f, we have the derivative changing from negative to positive. Because at the min and the max, what is the derivative? The derivative is 0, because the derivative is the slope of the tangent line at that point. Okay, so we're going to try to sketch a graph of f here. It says f of 0 is 3, f of 2 is -2, f of 1, 2, 3, 4, 5, 6. Okay, so I got some points of f. F prime of 0 is 0, f prime of 6 is 0, and f prime of 2 is not defined. Okay, so I got some points where I have critical values. F prime is greater than 0 from -infinity to 0 and 2 to 6. F prime is less than 0 here and here. So that means the function is increasing, decreasing, increasing, decreasing. So this would be a max, a min, a max. So let's see, at 0, I have some kind of max. So it's going to go like this. And it's going to be decreasing until I get to 2. But it says it's not defined, so I need to draw like. So let's check and make sure this is true. The function is increasing, decreasing, increasing, decreasing. This guy, the derivative is 0 because that would be a horizontal tangent line. And this, the derivative doesn't exist because it is pointing, a sharp turn. And that's what follows that. Let's try the next one. Okay, where is the function increasing and decreasing? So 3x squared plus 6x plus 3. Let's see if we can find a GCF. That's 3, so x squared plus 2x plus 1. So that would be, is that a factor? X plus 1 squared. So x equals -1. So if I was going to test -1, by plugging in something on the left, like -2, this is still going to be positive, both places. So that means the function is always increasing. So the function, let's see. There's not really much else you could do besides you could find zeros. If I was to set this equal to 0, like the original function equal to 0, and then factor out x, I would have x squared plus 3x plus 3. So I get x equals 0 as a intercept. And so it looks like this. Something like that. It's always increasing because the derivative is always, this derivative is always positive. So the function is always increasing. It doesn't have any places where it's decreasing. I know this unit can be a little tricky. So give the problems a try, and like always, please reach out if you have any questions.